Now let's turn our focus toward data types. And I want you to understand what a data type is because it will impact you when you're writing certain T-SQL queries. Now, a column in a table is a specific place. It has a specific position in the table and it holds a specific type of data. So notice this little example table. I used this way back at the beginning of the course in the Understanding Databases video. But notice we're keeping, obviously, information about somebody here that we want their first name, their last name, their age, the department they work in, and the pay grade or the level that they are. So if we look at this table, we can see some pretty significant areas that could be a problem for data integrity. Here's one right here, this age column. Now think about the ages of the employees that we hire and how we want this represented in our database. We want numerical data only. We want to see 23, 34, 43, just like you see here. Please do not spell out these numbers. Don't put for 23 TWENTY, THREE. That's going to be problematic when we run reports, when we try to do averages, all those sorts of things. Also, we don't want any decimals. We don't care if you're 23.6 years old. We just want to know if you're 23, then when you turn 24, we'll update it, okay? Also, we need certain ranges in here. We can only hire people between certain ranges in our industry. If someone tries to put in here someone who's 31 years old and they fat finger that and they put 13, we've got a problem. We've hired a 13-year-old according to our database. If someone's trying to put in 59, they fat finger that, they put in 95. We could have a problem there. So we want to make sure by using our data type, this is our first level of defense toward data integrity. It does kind of close the data down a little bit and limit it. Now, we don't want any zip codes, social security numbers, no phone numbers, no text, any of that stuff in here. So we're going to lock this down to a certain range or even a certain number of digits that can be put in here. And understand, very, very, very few people are out there trying to maliciously put garbage into your database. What happens is that just like you, they're doing 4 things at once. They're busy, they get off by a column, they input it, and if the table design was not designed to restrict what data can go in there, it will accept it, and you now have garbage and data that does not have any integrity in your table, and your data will at some point become useless. So data types are one of our first lines of defense in providing data integrity. Now, when your database designer created a column, they had to specify a data type. Now, there are more than 30 different data types in SQL Server 2012. And while you're not maybe a data designer or a database architect, the fact that you're going to be writing queries on these things, you need to understand these data types and the implications of them. The data types are divided into 7 major categories: exact numerics, approximate numerics, date and time, character strings, Unicode character strings, binary strings, and then there's this other that's kind of a catch-all for anything that doesn't fall cleanly into the other 6 categories. Now, I'm going to show you an example here. I'm not going to read all of these because, again, I'm not trying to teach you how to design tables in this course. But if you look in that exact numerics section, you'll see, for example, big int or a big integer. This thing uses 8 bytes of memory to store the data, and it can store a number that ranges from -2 to the 63rd power to +2 to the 63rd power minus 1. Now, what is that number? I have absolutely no idea. It looks like 9 bazillion, 223 gazillion, and so forth. Who knows? And then it goes to a positive 9 bazillion, 223 gazillion. And I'll tell you the big difference here. I can notice this from my 2nd grade math. This one's 1 less than this. So the positive one's 1 less on the range than the negative one. Or you could use an integer, an int. This takes 4 bytes of memory, and the range is -2 to the 31st power to +2 to the 31st power minus 1. Notice this number is a little more useful day to day, 2,147,000,000, both positive and negative, and some change. Now, you could track your salary in here probably. You could track things like total weight shipped per year. But do keep in mind, if you ship 2,148,000,000, then you're going to be shipping numbers that are too large to store in an integer data type, and you would have to jump up to the big integer. If you try to store too large of a number in a data type, you'll get what's called an overflow error. It can't hold it all. Small integer takes 2 bytes, and this goes from -2 to the 15th power to +2 to the 15th power minus 1. And notice that's negative 32,768 to positive 32,767. Now, this is a more workable number for a lot of different things, but keep in mind, if you've got a store over 32,767 in that particular column, in that particular cell, you're going to have a problem. Now, I'm not going to go through all 30 of these data types, but if you will go look in your working files folder, you will see a PDF that I've put out there for you called SQL Server 2012 Data Types. Now, I understand you may not be a database designer per se, but if you're getting this SQL certification, you're probably headed in that direction from time to time. And quite frankly, once you know something about SQL, you get pulled into all things SQL out there in the corporate world. So it would really be worth your while to go read about these data types. This is about 50 pages worth of data, so there's going to be some late night reading. And it's not exactly John Grisham stuff, so take it little bits at a time. But that will help you understand data types a little bit, and while you'll bump into some of the problems and some of the error messages you're going to see when you start writing queries.